Okay, I'm not going to bother with regular elements here. We're just going to say that y has an electronegativity of 3 and x has an electronegativity of 2. All right? And these are going to be, if you're going to have a trigonal bipyramidal situation, you're going to have an expanded octet. So when you're doing the Lewis structure, you're going to have extra electrons, right? So for something like XY5, what you're going to have is this. And I really kind of want you to picture it as I'm drawing it because I want to get into the angles and why this will be a nonpolar molecule. Assuming that all the atoms around the X are the same atom, and so therefore all the vectors are going to be equal strength, we can see whether or not they would cancel each other out. Okay, so for something that has for XY5, which is going to be like an X with 5 Ys around it, it's going to have trigonal bipyramidal electron geometry, and it will also be the molecular shape. The angles are 120 and 90. Let me explain why that is, okay? So what you really have here is you're going to have one Y coming straight up like this. I'm not going to put the dots on it. Another Y straight down. Now, while I'm doing this, let's talk about the vectors. You have one going up and one going down. These two are going to cancel each other out, right? It's almost like it's linear. So you have that. And then what you have is, so that's on one plane on a straight line along the y-axis, you have the x, y, y. And then you can think of there being a plane in the center. And what you have around the plane is like a Mercedes symbol. And so you have one y right on the plane sticking out like the letter T on its side. And you have one of them y's behind the board, and one of the y's in front of the board. And you can think of that as basically a mixture of a linear molecule and a trigonal planar molecule. On the trigonal planar, these guys are at 120 degrees, and that's where they're getting the angle from. And these guys, okay, these guys here are at 90 degrees, all right? Now make sure you're clear. The Y1, 2, and 3 are in one plane together, right? Making this Mercedes symbol, and they essentially cancel each other out as well. So if you have a molecule that's trigonal bipyramidal and all element Y is the same, it ends up being a nonpolar molecule. And you can see why there's two angles there, not one. Now, what if, okay, one of the domains is a lone pair? Then you have X, and then you have the Y up here, and the Y down here, and then you have the one sticking out of the board like this, right? And the one behind the board like this. This is called a seesaw shape, and the lone pair is right here. Now in this case, okay, what you can see is these two, this one here and this one here will still cancel each other out, but these two don't. This one is pulling towards the back of the room, this one is pulling towards the front of the room, and they don't cancel each other. Now if Y has the higher electronegativity, right, then that means this side is going to be partial negative and partial positive. And this is why when you have a seesaw, you end up with a polar molecule. All right. If, okay, you have a situation like this one, XY3, you're going to end up with an X here, okay? You're going to end up with the Y here, the Y here, and the extra Y right here, and the extra two pairs of electrons are right there, okay? These two do cancel each other out, but there's nothing to cancel out this vector here. And so this side ends up being negative, and this is positive. Okay, if it's just, let me just do some erasing here because it's getting a little bit messy over here, right? I'll erase this one over here. I'll do it over here. If you have XY2, okay, then you have an X, a Y, and a Y. It's just linear again. And as long as Y and Y are the same thing, the vectors cancel each other out. And even though you have individual bond polarities, you have a nonpolar molecule, and the angle is 180. Again, as long as you're able to use the chart, you'll be fine. You have this in CAS Learning. I'm now going to go to 6 domain. Da-da-da. Okay. Thank God we're just about done here, okay? So if there are 6 domains, all right, you have what's called octahedral. So you have, and the way you want to picture this, you have X there in the middle, and you've got like a Y up here, a Y down here, one Y. Now the other 4 Ys are all on a plane at opposite corners. So there's a Y here at one corner, a Y here at one corner, a Y here at the right. So you have this, along the Y axis, you have this, and you have a plane, right, the XZ axis, if you will, okay? and you have y's at 4 corners of that plane, right? And they're at opposite ends, so they sort of cancel each other out like this. Now all the angles here are 90 degrees, as you can see, all right? And because this cancels this, and this cancels this, and this cancels this, you end up with a nonpolar molecule. So things that have 6 domains like this, no free pairs, are going to be nonpolar molecules, okay? On the other hand, if you have one that's a lone pair, what you end up getting is what's called a square pyramid. So you can think of it this way. You have say you have X over here, right? And you have these 2 dots, right? And you have a Y up here. Now the Y is like at the top of the pyramid. And you have 4 other Y's here, and they're at the opposite corners. Now, if you want pictures like the Pyramid of Giza, right? You've got the apex of the pyramid, and you've got the 4 corners of the pyramid. And that's how you want to picture it. Now, these guys, this one right here cancels this one here cancels this one, but nothing cancels this one. And therefore, this side is going to be negative, and this side down here is going to be positive. All right? If you get 4 domains, I'm not going to even draw this one. If you have a total of 6 electron domains and 2 of them are lone pairs, you end up with square planar. What that basically means is this is gone. Right? And you got the 2 dots here. And because this cancels this and this cancels this, you end up with a nonpolar molecule. I'm going to erase this one's nonpolar. And I'm done. Okay, so I think we really covered everything here. So essentially what you should know now is this. You should be able to look at a molecule. You should be able to get a Lewis structure. Look at a Lewis structure, which is 2-dimensional, and figure out what the electron geometry is and what the molecular geometry is by looking at the bonding domains and the lone pair domains. You should know what the angles are. Now, the good thing is it sounds like the AP test is going to be open book, so if you have this chart in front of you, you know how to use it, you're good to go. Right? The hybridization, by the way, for things with 6 and 5 domains is not supposed to be on the AP exam. So all the SP3D2 and SP3D1, you're not supposed to even know. But since it's on a chart, who cares? You can look it up and find the answer for the AP exam. Okay? And then the big thing for me, and I think for the AP, is going to be, is it polar or non-polar? And just make sure you're clear, okay? Just because it's a square pyramid does not mean it's automatically, just because it's octahedral doesn't mean it's going to be nonpolar. It means it's going to be nonpolar if the 6 items that are around the central atom are the same. And you should be able to explain that, like say, the individual bond polarities cancel each other out. So even though the individual bonds are polar, the overall molecule is nonpolar and therefore does not have a partial positive side and a partial negative side, or have what's called a dipole moment. That's a lot of videos. Hope you got it all.